I'm Robin Leiter, and I'll be giving a presentation on the space tool that my mentor, Pamela Clark, myself, and a few other interns at NASA Goddard created over the past summer. The purpose of the space tool is to make CubeSat construction more accessible to scientists. The idea is that in the CubeSat early design stage, a scientist or a student would likely have a scientific goal and mission parameters in mind, but may not have the expertise or any satellite subsystem experts on hand to do a preliminary subsystem analysis. The Space Interactive Tool is a program that allows the user to do preliminary subsystem requirement calculations by inputting specific mission parameters. The tool also can search through databases of available CubeSat technology to give the user an idea of the capability and availability of CubeSat state-of-the-art technology. The tool separates the CubeSat design by subsystem and will sequentially take the user through the CubeSat scientific instruments, attitude control system, communication system, propulsion system, command and data handling system, and power system. The instrument selection page is the largest part of the tool and will sort through a database of scientific CubeSat scale instruments. It can first sort through the instruments by the type of instrument based on whatever the user wants to look at, such as sorting through cameras, spectrometers, magnetometers, altimeters, things like that, and looks through their detection range, like the wavelength, energy spectrum of the instrument, or the particles it can detect. The tool can then narrow by parameters like mass, size, and power requirements, and can display a list of the best options and detailed information about selected instruments if they're available. The next step is the attitude control page, which could help a user find attitude control systems that can fulfill the mission's pointing requirements, which are determined from parameters like the scientific instrument's resolution, its field of view, or the CubeSat's orbital distance. The command and data handling page can determine the throughput in bits per second generated by the scientific instrument and can estimate the CubeSat's data processing power requirements. These requirements are compared to the memory capacity, processing power, and clock speed of commercially available command boards for CubeSat. The communications page can perform preliminary link budget calculations for the CubeSat for selected antenna, transceivers, and/or ground systems. And the tool can help determine the maximum supported bit rate of the communication system. The propulsion page estimates the required delta V for a CubeSat's proposed trajectory in orbit using low-energy trajectory estimation. It compares these requirements to existing CubeSat propulsion systems such as plasma and chemical thrusters and air brakes, and displays their nominal, specific, and total impulse and delta V if available. Finally, the power page can allow the user to create a power management system for the CubeSat. Given the CubeSat's total power generation and storage requirements from the parts that they've already selected from their CubeSat, the program helps to choose the best solar panel configuration that can fulfill the power generation requirements and can determine the number of battery packs needed for the energy storage that you need. Finally, the program can output your design choices in a spreadsheet format, can help the user find links to various parts that they've selected, and it does a mass, power, and volume analysis of the CubeSat. It also displays the components, all the components that the user has selected as 3D modeled parts. As the CubeSat design and technology takes off, we want to keep this space tool up to date by adding new information to the database and new parts as they are developed and made available for commercial applications. We also hope to improve the space tool by cleaning up the code and adding new features to the tool, like improved mission parameter selection, different options for calculation, and assembled 3D diagrams, which we didn't get to over the summer due to time constraints. We'd also like to include an option to design multiple CubeSats for a single mission and do an analysis of CubeSat swarm performance.